In example 7.5, we are given a function. It is function f, has a domain of all real numbers, given by the equation f of x equals 2x squared plus 3x minus 1. And just like with example 7.4, we are being asked to find the difference quotient of f and also to simplify. So my difference quotient has the definition that it is f of a plus h minus f of a all divided by h. So I want to do some computations over here on the side. I want to look at f of a and also f of a plus h. Starting with f of a, though, we would have 2 times a squared plus 3 times a minus 1, which is really just going to be 2a squared plus 3a minus 1. And then we'll do the calculation for f of a plus h. That is going to be 2 times a plus h squared plus 3 times a plus h minus 1. So the f of a plus h calculation is typically going to be a little more involved than f of a, simply because a plus h is more involved than a. So you have 3 terms in the expression for f of a plus h. The first term, you're going to need to take care of the square first, and then on the second term, you'll want to take care of the distribution there. So this is going to read 2 times a squared plus 2ah plus h squared. So that's what the first term looks like now. The second term is now going to have the distribution, so it's going to say 3a plus 3h and then minus 1. Now I'm still not quite done with the first term. I need to go through and distribute now by 2. So I will have 2a squared plus 4ah plus 2h squared, and then I'll copy down the rest of the terms after that, and voila, we have the expression for f of a plus h. So we're going to take these results and we're going to substitute them into our difference quotient statement, starting with f of a plus h. And I know that it's going to get a little lengthy here, but if you stay with the process, you're going to find that some really nice things occur. Also bring in f of a, and that whole numerator is divided by h. So remember, this is called the difference quotient for a reason. There will be a round of cancellation due to the difference, and then there will be a cancellation due to the quotient, and it's in that order. So for the difference, 2a squared minus 2a squared, that's gone. 3a minus 3a, that's gone. And then negative 1 minus negative 1, there's your last cancellation. So the numerator is not going to be near as expansive as it first started. It's now going to say 4ah plus 2h squared plus 3h all divided by h. And that already looks significantly better than where we started. But there's more, because we've only done one round of cancellation, and that was due to the difference. Now, I should recognize that I can factor in h from the numerator, and I'd have h times 4a plus 2h plus 3 all divided by h. In which case the h's can now cancel, leaving me with the statement 4a plus 2h plus 3, provided that h does not equal 0. And that will be the difference quotient of f, completely simplified.